Okay, I think looking everything perfect. Now we are live. Hello, welcome everyone to GopherLab episode 2, the case for deep learning in Go by Chew. And we have joined another creator of Spargo. And welcome everyone to this stream. And we are really going to discuss about Go with machine learning, real pure discussion, deep, and you can post anything in comment, whatever your questions. And we have another great library called Gorgonia. It's one of the most popular library with 3.5 star. But who cares about stars? Get star. Let's see the demos, and we can learn more thing around Go and machine learning. Welcome everyone. Welcome Chu and Matt. You can introduce yourself.
Matt, you can go first. Matteo.
It's too polite. All right. Well, we meet already yesterday in the first episode with Spago. Well, my name is Matteo Grella, and I'm working for many years in the field of artificial intelligence, and I'm heading the software department of the EXO group for security management and risk analysis. We are applying there, we are deploying the library Spago. So I think this is a short introduction I can make to don't lose important time for the introduction of Spago today. Take more time.
Sorry. Anyway, hi, I'm Chew. I'm Chew. I'm the primary author of Gorgonia's family of libraries. Gorgonia is not a single library. It is a family of libraries, and it does a lot of other things, right? So I'm the primary author. I've been in machine learning for 15 years ish. And back in the day, we were doing things like SVMs, like support vector machines and building support vector machines, and now we're doing deep learning. So I've been around for a very long time, from the days of Surf. And if you don't know what Surf is, it's basically an image recognition kind of thing. Image pyramids, for example, that was so popular back in the day. But now everyone's using convolutional neural networks. So I've been around the block for a bit. I got a degree in economics. I don't actually have a degree in computer science. But I've been programming since I was a kid, so that's a bit of a difference, right? So yeah,
that shows your passion about computer science, and also you have done other degree in economics. It's like really great. It's like an entrepreneurial journey, and you have a financial, like how money works, and you know the coding from the basic. That's really great. And a little bit about me. My name is Sangam Birada, and I am a Docker community leader, also terrific traffic ambassador, and Octato community leader. I run multiple communities. You can name it, Rust or Go, and this is my channel called Coop Daily. So I'm on a mission to share, connect with people and share more into the open source community. So we have a great project today, and already we have discussed about Spargo, and today we are going to see about Gorgonia. Let's start. What is Gorgonia? And before that, I want to ask you, like, how you started this Gorgonia project. What is the, like, what is the, is it like business, or you are doing some kind of project? Like, how you started?
So we have to go back to a bit earlier, like 2013, 14. 2014, there was no real deep learning packages back then, right? So you wanted to do deep learning, you use MATLAB. I'm not joking. You can do deep learning in MATLAB. And then Theano came about. Python had this thing called Theano, and I was already programming in Go since 2010, 2009, 2010.
Okay. So you are early Gopher.
Yeah, I was there. So I live in Sydney, and Go was actually announced in Sydney first around the world. So I was in that. It was a Google's user group that I was in, and it was a very hush sort of secret announcement. We've got an announcement about something. Yeah. I was in that room, and Rob Pike and Andrew, I think it was Andrew Durand came about, and they just introduced Go. And then it's like, that's a cool one. No features at all, but hey, concurrency, that's a very nice thing, right? So, but I've been programming in Go since 2010, and in 2013, 2014, there were no real libraries. Piano was one, but then in order to use Piano, you needed to install all sorts of funny shit. I hope you don't mind me using shit, the words like shit, but all sorts of funny shit. And whereas in Go, you can just like go build dot, and then you take your compiled file, and it runs on any computer that has the same architecture, right? If you're running on Linux, you can take any program I compile in my current Linux and run it on another Linux, x86 obviously, but it's a lot more portable than the Python stuff.
How you started, Matt? About like your journey, like I'm like asking Matt, how you started like into like Go and machine learning?
Well, as I said before, I always been fascinated about artificial intelligence, and when I was really young, I wanted to create a robot, a humanoid, and so I started with electronics and hardware. And after a while, I realized, okay, but then I have to talk with the machine. The machine needs to understand me. And so I studied linguistics, and then I discovered computational linguistics. So I specialized a little bit there, and I tried to program by my own a lot of softwares, hundreds of softwares, every time doing the same things, try to understand the language. And I experiment with Pascal, with Ada, with Lisp, with Java, the version probably 6, and then I rewrite to the version 8, and then Kotlin, and then of course Python. But I was never satisfied about the programming language. I know that for a serious programmer, all the languages are mostly the same, but there are some concepts like object-oriented programming, also the way you program with like static methods, etc., that didn't make any sense to me anymore. And then I discovered Go, and I say, wow, that's cool. That's really minimal syntax. It looks quite efficient. It's a single executable, so no dependencies. As you said, it's just a single executable. And I said, wow, that's my language. And I wanted then to learn Go. And I also wanted to turn myself more machine learning, because when you do computational linguistics, it doesn't imply that you're doing machine learning or deep learning and all this nice stuff. So I thought, okay, why don't combine these two objectives? So me learning Go, me learning again machine learning, trying to building a library useful also for someone else. And that's why I jumped to Go and created Spago.
I got a question for you.
Yeah.
Sorry, can I butt in? I got a question for Matteo.
Yeah.
So you know about Lingo? Do you know about Lingo?
Yeah, I do.
Okay. So Lingo, in any case, anyone doesn't know, Lingo is my version of, I don't know, Spacey, NLTK, who cares, right? It's written in Go. It's called Lingo. But I have a bunch of books on linguistics, right? And so my question to you is, what's your favorite book? And do you believe in universal grammar?
Not really. Give me a second. Because I have the book there.
I think he has like full library of books. Yeah, there we go. The big books.
Oh, love it. I can't actually see it. What's
Yeah, you can. Yeah,
I don't know if you can.
Constraints and language. Okay.
Yeah, because I'm one sustainer of symbolic computation. Of course, I have then to admit that the power of deep learning, so vectors, embeddings, playing each other in some mathematical fancy way, is really powerful and allow to get immediate results for natural language processing. But on the other side, I think this is not the right direction. I'm really a big sustainer of a sort of engine, natural language engine in our brain, which are more than a mathematical operation. It should be a structure to understand how to understand language. and also to rely on some constraints, really naive on our brain on how language works, which is completely different than the current machine learning and the super parrots like transformers methodologies. And that's why this book of constraints and languages from Philippe Blanche and other really cool authors, I think is nice direction. It give you a nice perspective on how you can express linguistic rules from morphology to syntax to semantic, more in a constrained way, closer, I guess, to what we are doing when we understand language.
So, what are your opinions on merge? Chomsky's merge.
I'm not so sure. I have to think. I have to think a bit how to answer that question.
So, okay, sorry. You seem to be very bought into the whole universal grammar thing. Then you believe that there's a structure in our brain.
Well, yeah, exactly. Universal grammar is my favorite theory. It's really broad, but together with the optimal theory and also gradation of natural language. For example, I know my English is really bad. However, thank you. However, I think I can express myself well enough for you to understand. And that also means that your language understanding is quite flexible, because I'm not respecting all the right phonetical rules. I'm not respecting most likely the grammar and the syntax. So it's a sort of gradation, the way your brain parser, your brain language processor is analyzing my utterances. And I think that's the way that universal grammar, optimal theory is. I mean, that would be the way. And please also consider that our brain consume, is proven, I cannot give you references, but 20 watts in order to do computation. And with machine learning, we need the GPU, we need to train GPUs or TPUs with a lot of power, a lot of net energy. And, GPT-3, the general pre-trained model.
I'm going to ask you about GPT-3.
Yeah, I mean, it costed 12 billion, if I'm not wrong. It doesn't make any sense. So
you need to power generate. You need a sort of hydroelectric dam to run GPT-3 essentially.
Yeah, I mean,
my thing is that I'm not into machine learning, like how you think, like how brain and neural network. I don't think about that. I first think about that as a programming language, as a human, what we study or what we do. Let's say I have written a code in C or machine level or anything, how it's like how it's easy to understand for machine. That is my primary thing in everything, and simplicity of that. Let's say we have different programming language. It has cool feature, everything has cool feature, and it cannot be used in everywhere. Okay, it has, like, you can use HTML for web or something for this, but I think we don't need to see the syntax of the language or how it's. I'm more into compiler design, how compiler design work, and what is the grammar of that particular language, and how it's going to communicate with the machine. That is very important. If you are taking more computation power to run any machine learning or anything in any kind of computation power, you need more power, and that thing we are putting more efforts. We need more easy way. Let's say about Go is something easy to understand for, as a syntax is very clear, everything. But when you compile these things, it's more close to the compiler or machine, and it's give you Go routine and concurrency. This kind of thing always fascinated me. And Go is something has, maybe I'm not talking about like machine learning primarily. Let's say you can take machine learning also, you need some kind of computation power in the end. you need a CPU, GPU, but how can we optimize that rather than using more thing? Let's say I want to run something code, and I'm using the 10 GB of memory containers. I'm running this kind of infrastructure, and for the hello world application, you need this kind of resource, this much resource. Why? That is my
Yeah,
question.
exactly.
Why we cannot do things a simple way that better for human and better for machine? And that's
It's
where
not
I say,
necessarily better for machines, but yeah, go on.
yeah, but as the respective of what I understood and machine learning, we train things and then we predict things. It's like more into uh, statistics and probability
Yep.
more, and mathematics thing. If you are good at mathematics, and computer science is a subject of mathematics, I already believed that, and it is good. It's always fit machine learning into computer science. So yeah, we need to do more better way, I think. More it's just a start of machine learning, I think.
Yeah, I
And
agree.
yeah, this is just a start of
Yeah.
cloud native. Maybe we are seeing is like we are experimenting thing. And as I say, when we say AI, there is no machine or some kind of component that perfectly uh, not used by the machine learning or automated. It's all automation. We are in phase of automation. We want to make our life easy. That's it for me. And what kind of problem solving for humans? And I like books. I like books where the math and everything is there, but I want to do things more easy way so people can understand and common people can use this technology. If it's can use by something, it can solve a lot of business problems out there. And this is my thought. And next question to both of you. You are a maintainer of open source two libraries, and how was your experience to maintaining a Gorgonia from starting, how it started project, and how people collaborate? First you can go to, and then after that I can ask same question to Matt.
Okay, cool. Yeah, so the Gorgonia community is amazing. I mean, someone else other than me wrote a book on Gorgonia.
Oh,
Yeah,
that's
right.
That's cool.
So that's how amazing it is. I really love working with everyone in the community. Basically, because it's so small, it's still manageable by email, and pretty much email and Google Calendar and now Zoom are the things. I have tried playing around with Visual Studio Code live coding sessions.
Mhm.
I'm not particularly a fan of it. Like sometimes contributors need some help, so I would jump in on a Zoom call with them to do that. But I don't know. I find Visual Studio a bit weird. It's not Emacs, right? So yeah. With regards to communications and how things are being done, email is the best way forwards. Not so much chat. We have design documents in Google Docs. I just showed Mateo one earlier. So we go through a lot, and for me personally, as a maintainer, when I try not to add features as much,
Mhm.
I try to keep the features sane and provable. So Gorgonia is one of the stranger libraries out there in Goland because some parts of the library has been proven to network to be it'll never fail.
Mhm.
So I use things like cock. Not sure if you guys know what cock is. No.
No,
Okay.
even I.
Cock is basically a programming language.
Okay.
And what you do is you type in your specification, and it's a theorem solve. It's a theorem prover. It proves your theorem for you. It says, I believe that this is the premise. I believe it's premise A, premise B. Therefore, my theorem is C. It will prove C for you. So, like you said, Sangam earlier, computer science is mathematics,
Yeah.
and the best way to do that is to provide proofs. So, parts of Gorgonia has been proven by Koch and Idris, Agda, and then they've been translated back to Go, and often the translation from Koch or from Idris to go is broken. So yeah. So with regards to that, I try to not add as many features. So most of the features that you see on Gorgonia are community added.
Interesting. Community first.
Yeah. No, yeah, sure, yes.
Yeah. What about you? Like, what's Pago?
Well, I'm following a slightly different approach respect to Gorgonia right now. I started creating the basics for a machine deep learning framework. So all about the mathematical part, the so-called computational graph operators. And then I also built up in the same project, so again in Spago, a lot of neural networks architectures, also called modules or module. It depends on the framework you work on. In our case, I just call models. And I built models for recurrent computation from the most famous LSTM, the long short-term memory, and a lot of models, because my first objective, as I said before, was to learn myself. And my favorite way to learn is to do it from scratch. And only then I can profoundly, deeply understand what is going on. So my approach was, okay, I wake up in the morning, I read a paper, a machine learning paper that I like. Let's try to implement that. So less community or robust oriented. I just wanted to create models, also to understand if the basic concepts of the machine learning and automatic gradation frameworks were working or not. And so I also try to create a unit test to understand if the bases were right. And after a while, I realized that nobody were using Spago. Also the stars, I know the stars are not so important, but they are in another way, and we're not growing. So I thought, okay, why don't try to bring some other value and to specialize a little bit more Spago in natural language processing, which is my field. It's where I'm comfortable. It's my main passion. And also there, I had two options. One, let's follow my heart, my old school, my old-fashioned schools with post-tagging, dependency parsing, and a lot of tasks which are...
I love those.
Yeah, I'm loving dependency parsing. It's 20 years I'm creating variants for the very same task. But then I thought, no. Let's try to create something that other people can immediately use in their own product. And luckily, or not, it depends on the perspective, now we have the transformers models, BART, BERT, GPT-3, GPT-2, Albert, Transformer XL, thousands of models implemented in a sort of acceptable, high quality from Hugging Face, which is a nice company releasing not just open source code, but also pre-trained models for those architectures to perform automatic summarization, question answering, zero-shot classification, etc. So I thought, okay, let's bring apart a bit my main passion for dependency parsing, which at the end they created a tree of grammatical structure. Nobody's really used that. And try to take advantages of those models inside Spago. And then the magic happened then, because I built then gRPC servers, HTTP servers, relying on all the machine learning part of Spago, but then you can get results straightforward, immediately. You type a text and you see results. You see the entities, person, locations, organizations, you see the summary, etc. And what I discover, backing about the original question about the community, the majority of the people that are looking at Spago, that are trying to use Spago, is not for the basic machine learning framework, which is the part I'm more proud of at the end, but for the final parts, so for BERT, for question answering, text similarity, etc. And a little bit of spoiler, I think at the end I will split the Spago project in a core Spago, only for machine learning modules, and the other part more NLP oriented
Makes sense.
for transformers, etc. It's a clean separation, but not right now because I want to have one single project as much as possible, because indeed we have also satellite projects that support Spago, to engage users and to enlarge the community. And well, it's really hard, at least for me, to build up this community. I haven't really made any marketing out of Spago. So it's just people looking for some tags, or now, thanks to you, Sangam, our talk, and then we might bring more people to Spago. But yeah, community is hard. I'm pushing issues as much as possible rather than private communications in order to, try to engage people. And please remember, this is also not my full-time job working on Spago. I'm on security management field. So try to combine wife, the dog, and the community. Well, it's quite hard. Yeah, but that's how it is, and I'm quite happy.
Yeah, so I really like Spago. I have used it. I understood how it's like designed, and I really like how you created a CMD client, and after that it's taking the pre-trained model. After then using of gRPC gateway is really fantastic. I really like that way of how it's internally structured, and that can boost a lot of things. And I can get if I'm like not from machine learning background, or maybe I'm a fresh user, I want to just use NLP and machine learning. I think Spargo makes sense to like go and pass your like JSON files directly data, and you will get direct output. And that what make people like, if someone want to reuse those libraries, and it's very easy to understand, and there are like straightforward already pre-trained model they can use, and they can use add their own models also. That is like really cool thing. And today I'm like excited about choose Gorgonia project is like very huge. I went to the GitHub repo and I tried to do some kind of thing, but I'm excited to learn from you guys, both of you. So can you start with like demo or like introduction part? I want to
Yeah.
share something. Yeah, that will be great.
So the introduction, I think, is going to be a bit weird, right? It's going to be a non-standard introduction, but I've done it so many times I can do it again and again. So when you think about deep learning, people think about artificial neural networks. They think about brains and neurons, and they see neurons, right? But what I think of deep learning is not that. It's not any of that. It's just a mathematical expression. You are familiar with mathematical expressions, right? So, for example, can you see my whiteboard?
Yeah.
Okay. This is a mathematical expression, w plus 1. Yeah? This is a mathematical expression. And this is a mathematical expression. Am I still there? Hello? Okay.
Yeah.
Anyways, sorry.
You can explain.
Yeah, so this is a mathematical expression, right? So let's look at w plus 1. Let's just call this x plus 1, right? X plus 1. This, if you write it down, is basically a tree. Can you see this? Right, so this is a tree, and if you replace x with a value, so you say let x equals to 5 in x plus 1, right? Then you replace x with 5, then you say your tree now looks like this. And then to get the final value, you simply take this node, and then you add them up over here. You just walk the tree from the leaves to the roots. Simple. So in that sense, that's what a mathematical expression is. And what Gorgonia does is it gives you the ability to write mathematical expressions. And why do you want to do that? Well, the key thing about machine learning, the key thing that makes deep learning work so well is something called backpropagation. And what backpropagation is basically you've got a function that predicts inputs and outputs, right? So if you take an output and then you see hot dog or not hot dog, right? You've got two options, hot dog or not hot dog. So if you predict hot dog, but the actual thing is not a hot dog, you need to tell the function to update itself. Does that make sense? So what you do is you backpropagate, and backpropagation is basically partial differentiation in disguise. So you basically say, let this equals by, and then you say you want to update it, so you let dy over dx, the partial differentiation of dy over dx. When you have a tree, it is very easy to do backpropagation. And backpropagation comes in very many forms. It comes in forward kind of backpropagation. It comes in one way you can think of backpropagation is you take the tree and you add more nodes to the tree. That's one way of backpropagation. Does that make sense at all?
Absolutely.
Yeah, and then the other way you can think of backpropagation is a forwards mode backpropagation. So as you go forward, you collect more gradients, and then you move the gradients backwards. And then there's also reverse mode differentiation. So when you go forwards, you have gradients come backwards at the same time. So Gorgonia does all three kinds of differentiation. You've got symbolic differentiation, adding more nodes to the tree or to the graph. You've got the forwards mode and the backwards mode differentiation. And that basically powers deep learning. And the rest are all implementation details, right? The implementation to whether run it on a GPU, to run it on a different CPU, to run it concurrently, to run it parallelly. All these are implementation details. And basically we've worked out a bunch of implementation necessities. What is really necessary for a modern day programming language to have as a library. I gave 2 out of 3 planned talks, right? So in 2017 in GopherCon Singapore, I gave a talk on efficient multi-dimensional slices, which are called tensors. Tensors are basically like your slice, but multi-dimensional. In 2017, I gave a talk about how to build those. And I think in the 1 minute 45 mark, Matteo has, if Matteo watches it, he'll have a bit of an Easter egg there for him. But basically in the first 2 minutes, I showed that you can take a tensor and transform it into lambda calculus. And I think everyone is familiar with lambda calculus here. So yeah, you have
a question, if I may. Why did you implement all those types of automatic differentiation and not just one that could be like the fastest? I don't know. So there's any reason why you decided to implement a different type of automatic differentiation?
Yeah, so they're not all the fastest. Does that make sense? It's not going to be the fastest for a specific option. For example, take recurrent neural networks, right? You often have to do truncated backpropagation if you add to the nodes, if you do symbolic differentiation. But if you have a backwards or forwards mode differentiation, you can go as far as you need, because all you need is as much memory as it is as long as your RNN is.
Makes sense. Makes sense.
So it's not fast. So it's it's performance based on your requirements. If you have a convolutional neural network, you know what? Just do symbolic differentiation. You know, if you have a recurrent neural network, you should do something like a forward mode differentiation. I found was the most effective, most efficient, all things considered. And then if you have recursive neural networks, now that's very interesting, right? Recursive neural networks are neural networks in neural networks in neural networks. It's a bit of a mindfuck. I gave a talk last year at Yao on this. You use the neural network to find out what's happening inside the neural network, the same neural network, to find out what's happening inside the same inside itself. And in those cases, you want a mix of differentiation styles.
That's very interesting. It's really fascinating because I think that the graph neural networks can benefit a lot of mixing the two strategies because, graph neural networks are sort of autoencoders in a way, recursive, but can be also recurrent or convolution. Wow, that's really cool. Yeah.
So there are only 3 kinds of differentiation. All 3 kinds are supported in Gorgonia. I took a lot of time, a lot of effort to figure out what the correct thing is, and this is one thing I want to make right. This topic of this show is the reason why you should use Go for deep learning and not Python. Python is easy. Don't get me wrong. Python is fantastic. It's easy. It's easy to code. It's easy to read. And on the first look, it looks like Go is hard. It's difficult, right? But
I will say like Go is like very simple to learn, but very difficult to master.
Yeah.
I disagree with both of you guys because for me, Go is easy to read. Yeah, I would not say I'm mastering Go, but I'm not afraid to touch other open source softwares because I can, as I understand, I think I know how to write and contribute and do some coding. In Python, I think, my personal opinion, the syntax is horrible, the indentations, and yeah, guys, I'm not afraid to say I detest the Python. The flexibility you have, I think, can be counterproductive. If you mix the flexibility of arguments, always can be stored in a dict, in a hashing table, and the flexibility of tensors. Wow, you came up that it's so hard, especially in machine learning, to understand what's going on. And that's the experience I have with some of my colleagues trying to understand what I was doing in PyTorch. And they say, well, that's not normal programming. I can understand. I cannot debug with easy. Rather, in Go, as it's all explicit, I know every time what type I'm doing with. We don't have that much hierarchy among objects. So I think Go programming is much more straightforward, also for machine learning in that case.
And surprisingly, the Zen of Python itself says there should be one, and preferably only one obvious way to do it. Although that one way may not be obvious unless you're Dutch. I mean, And I think in a lot of cases, I think Go is follows the Zen of Python more than Python itself. If you consider the things that Python allows, it's just ridiculous, right? So that's one of the things, right? This show is all about making the case to use Go to do your deep learning. And I think, can I share my screen?
Yeah, you can share screen, and before sharing screen, just I want to share my opinion on this, whatever. Go and learning. So what I think is that when you are running threads or like parallel processing, it needs some kind of parallel processing and something. In Python, I thought it's not good with memory management, how things going to work, and it when you train model or something, it take too much time, take too much process and thing, and we can achieve that thing with Go routine or like concurrency that can boost like very faster. And one more thing is that a dependency management system, Go mods, that allow you to use anything. Maybe you are adding like system thing or maybe anything you want to reuse. That's very cool, and it's like advanced. Go is like advanced.
Yep.
It's like very clear syntax, everything. So anybody can learn easily.
Yep.
Yeah. So you can share
Absolutely. Yep. Okay. So the point I'm trying to make is this, right? So
yeah, got it. Yeah,
the screen that I'm sharing is that
yeah.
the work that you do in deep learning is of and in data science, in fact, is a mix of statistics and software engineering. It's in between. And if you consider, right, the ad hocness of work, like how suddenly you need to jump in and do it, and then and then your program goes away and people forgets about your program. You got scripts on this end, like scripts, simple shortcut scripts that you write, and then you got services on this end. Does that make sense?
Yeah.
Yeah.
So this actually corresponds more or less with in the data science work as exploratory work. When you want to explore data, it's you write small short scripts, look at the data, then throw away the program, right? And then eventually you need to put these models into production, and so you need to turn them into services, right? Now let's consider the y-axis. How hard is it to get things done, right? So in Python, it looks like this. It's very easy to get short-lived programs out. It's very easy to start a boot camp. It's very easy to read a Jupyter notebook, write a Jupyter notebook. But it's quite considerably harder to do that on as a service, right? People are doing really crazy shit. Sorry to say this, but people are doing really crazy shit, like packaging up Jupyter notebooks into services. I personally don't think that's a great idea. I think that's a crazy idea. That's nuts. But in Go, it looks something like this. Your initial effort is slightly more, but it pays off at the end when you need to servicize something. Yeah, and as a a bit of a joke, my favorite language, Haskell, which is it looks like this. But the initial effort, even in Rust, the initial effort is very high, right? And now you consider where most of the deep learning work actually sits. They sit somewhere around here. They're not around here, right? Because by the time you start going down and optimizing every single kernel that you have into assembly, the models would have moved on. LSTM lasted 15 years, and it is only really in the last 4 or 5 years of that 15 years that it became big and popular, and then immediately it was taken over by transformers, right? Your lifespan is not very long, so you don't have to worry so much about writing programs that last 20, 30 years here. And that's essentially one of the best reasons to use Go, because Go allows you to write robust programs without much effort at the end. Your payoff is at the end, right? So that's essentially it.
Let me add this on stream. Yeah, that looks good.
Hmm?
Can you like a little bit zoom?
Sorry. Yeah. So this is there's nothing more permanent than a temporary hack.
Yeah, that's cool, man. Yeah, just like want to share my thoughts on like you come up with like graph of programming and what is my take like on why Go in general, or
Yeah.
you can apply anywhere. You can apply anywhere, maybe data science or anywhere you can apply. So let me share my screen, and this is my screen, and let me zoom a little bit. Okay, now I think it's
I think you can
visible.
go full screen, right?
Yeah, let me make screen share. Like, is it not working? Let me refresh it once. This tab. Hmm, okay, let me try once again. Let me try once again. Maybe because of some stream lag. Okay, so let me remove this one
Okay.
because of my browser is like a little bit taking too much time. Mm, oh shoot. Okay, now everything fine. I think okay, it's working. Okay, you can see this graph. Now
Yes.
we have two things. One is running. We have fast and fun for human, like easy to understand for human.
Hmm.
And one thing, one graph, fast, efficient for computers.
Yep.
And we need to think that maybe in between or beyond that. And it's good for if it's compatible with both of things. Okay, let's say for the humans also, for the computer efficiency and fast, how you want for that also. So I think Go is somewhere beyond the Python for the efficiency and for the computers, and
Yep.
that I think that can give a much more clarity to use. And let me switch my next slide. Okay, perfect. Okay, so this is the next slide, which is talking about beautiful straight code.
Yep.
And after that, if concurrency is something very, it can boost your language or you can boost the productivity. It can run easy faster way on lightweight. It's make very lightweight and easy. So here is a graph. We have Python and this JS and Perl. This is very low efficiency. There is no good currency. Java, C++.
I find it weird that you put Erlang underneath Go.
Yeah, this is old one. This is old one.
Yep.
Uh,
Okay.
yeah, this is very old one. When Go is started, there is like talk on why Go. So it's like
Ah.
that. So still, you can see you have already have experienced coding in different language, and when you code in Go, it's like similar to C and C++, and
Yep.
even that Go routine and this all thing can like boost up lot of things, and and one of the straight code is very important. And I like one of the most beautiful thing is that as a programmer we do a lot of mistake, and we literally describe the variables and we don't use it proper way. And in
Yep.
Go, when you use the variables and we don't declare its error, and that's very clear and straightforward, and use whatever you need, and very lightweight and minimalistic and straightforward. And that is
Yep.
one of the thing can like, and anyone can learn Go very easily. Those who know C or any programming language concepts, they can directly start.
Yep.
Yeah,
Yeah.
that's yeah, that's it. Like you can start, or like you can show the demo or any slides more into
Ah.
Gorgon.
Yeah. Sure. So I think a fun demo to show would be um. So the Gorgonia library itself comes with several examples. Car RNN is one of them. We generate fake Shakespeare or fake Paul Graham or whatever. That's your typical stuff. You've got a typical convolutional neural network. And one of the things that you can do that I showed Matteo earlier was this. Let's see, how do I share my screen? Okay. Can I share my terminal?
Yeah, you can
Can I
share
share my
terminal.
Could you repeat, please?
I showed this to you earlier, right? So this is a Go program.
You are not sharing your screen.
Yeah,
Yeah. Okay. Okay. Now I see. Okay.
can
So
you
this is
like
the
little bit zoom it so it can be like, yeah, maybe
good.
like maximize the your length of the terminal. Yeah, this perfect one, and you can little bit zoom, little bit only. Yeah, so
Zoom
yeah,
out or zoom in?
yeah, now clear.
Okay, so this is a Go program, right? With plenty of so this is the basic Go program, but here's the part, right? So you can see you can see having different D types, for example. So I compiled the program, and this is on float 64. So it reads the data as float 64, and it takes about 5-ish minutes to finish one epoch of training. But if you do this, and now it goes much faster. Over time, it goes much faster. Yeah.
Yeah, that's impressive. And yeah, this is why we are thinking to team up at the end our projects, because that's way faster than Spago. And we might use Gorgonia as a backend for Spago in order to speed up the computations using exactly those strategies.
Yeah, so Gorgonia has pretty mature on that front. And for a bit of a live demo, I guess I can show you my Emacs. So over here, okay, is this good, bad? Do I need to zoom in?
It's good. You need to zoom it. Just like let me like show full screen, only your screen. So now you can zoom it.
Okay, so let's kill these windows.
Yeah, maybe.
I have no idea how to zoom.
Yeah,
Believe it or not, I have no idea how to zoom. One second. How do you zoom text in?
What you are using? Like you are using terminal?
CXC plus. Okay. No. There you go.
Yeah, you can zoom little bit. It's like too much smaller. It's too smaller. Even I cannot see. Yeah, now more little bit. Little bit
more.
Yeah.
Little bit more.
Yeah.
This.
Yeah. Now it's perfect.
Perfect.
Okay. So this is basically Emacs. I should also zoom this in, right? So.
Yeah.
Okay, so this is a function. It says create me a new tensor with a shape of 2 rows and 3 columns. And I want it to be an integer range from 0 to 6. And then after that, I'll print it. It's very simple. Does that make sense?
Yeah.
So you've got a 2 rows and 3 columns, and the data is basically laid out as 0 to 6. Now let's change this to a float. And instead of doing this, we do printf. And now if you run this again, you'll see it's actually a matrix of floats. Yeah. And by the way, when they say Go has no generics, what's this? It's generic. And not only that, right? So it's generic enough to be run on GPUs. So I wanted to show you this, but I am on a computer right now with no NVIDIA graphics cards, so I can't actually do it. But basically, there's a library in Gorgonia called CU. And this basically allows you to run your tensors on graphics cards.
Yeah.
There's a lot of setup required.
Yeah, I can give a try on Jetson Nano with Jetson Nano.
I'm not sure if it works on a Jetson Nano. I have not tried it. So yeah. Also, we can do something like this. It's not only a matrix, right? You can have 2, 3, 4 would be 24, 0 to 24, and say for shits and giggles, we call this float 32. And now you have a tensor with 2 layers and each layer has 3 rows and 4 columns.
Yeah.
And this is the result.
It's quite impressive. I can easily imagine how much effort is behind to obtain this high-level API in Gorgonia. Wow.
So for example, tensor dot with shape for 5. Let's say tensor dot. So this is one way of doing multiplication. And let's see what C is, right? So this is one way of doing multiplication. And 3 times 4 is 12, not 24. A is 3 times 4.
Wow.
So you actually tell. Sorry?
Yeah, got it.
Yeah.
So here you are showing that the multiplication is not working because of shape mismatch. Okay, I got it. Yeah.
I think it's B. Yeah. So you can also do this. Oh, the one thing I really regret is this. So it looks like NumPy. It gives you a matrix multiplication, but dot is such a tricky option.
Mm-hmm.
So AB, and so these are the basic tricks with 4 5. Sorry, A is 3 4 4. 3 4 times 4 5 is, sorry, matmul. I think it's matmul. Anyway, there you go.
Yeah.
So this is matrix multiplication. 3 4 times 4 5 gives you a 3 5 matrix, and that's not all. So let's say you want to have pre-allocate your So basically, I want to pre-allocate an empty matrix. And then over here, I say I want to fill in the blanks with I want you to put the results in this empty matrix that I created, right? So that's this, and let's call this D. Am I going too fast? Are you guys following?
Yeah, I'm following, and I'm really fascinated because that allows you to make aggressive buffer and avoid to reallocate every time a new matrix, which is quite time-consuming.
There you go. Yeah, exactly. So that's exactly why I created it.
So just to understand, so with the reuse, the final result is the pointer, is the very same variable, the very same pointer to C, and you also obtain back to the, wow. Yeah, exactly what I meant.
It is true.
Okay, so at the end, you have a clean API implementation because it doesn't matter if you reuse or not.
Yeah.
And you always get a result back because other libraries that I know of, they have variants. So you might have a matrix multiplication with a receiver, and then the API, the high-level API will change. And you manage that the high-level API doesn't change, and still you can use. Well, I'm impressed. Really, congratulations. Really compliments.
So
Wow.
that's essentially the idea of the tensor library, right? And the tensor library has something inside each tensor. There is something called an engine. If this runs, so the engine here is the standard engine, but you can build your own engine.
We can see the last print. If you can just
Yeah. So let me just try this again. So the last line is the default engine that it's built in, but you can basically use this and extend this yourself. Would you like to see that?
Yeah. I mean, so basically, you can the engine is the piece of software that perform the actual operation, and that means
correct.
that if you write your own implementation in assembly, let's say assembly, then you can run the operation there. That also would mean, if you understand me right, that the CUDA, so the GPU operations, you don't have to change tensor. You just say the engine is different, and the engine is for CUDA. Do I right?
That is correct.
Wow.
So let me show you lat long, for example. Right? So this is my type. It's called lat long, and well, we need to define my own D type. So I think that's the one. Reflect dot type of lat long. Yeah. So dt equals to lat long d type. dt. Oh wait, hang on. You cannot do this. I'll create a new. And anyway, so let me show you creating your own engine, right? So type my engine. So I basically inherit the definition of my engine, and now I'm going to do something funny. This is just, I'm going to copy and paste from somewhere else. Okay, let's not call this lat long d type, call it my d type, just right. So if it's my d type, you do something about it.
Okay.
Does that make sense? So I basically put a new upgrade the add function of the engine. And now
I think it's worth to mention that you are overloading the add function, I think, from the standard engine, right?
Yeah, not overloading. You are not overloading. You're extending. There's a difference between overloading and extending. You don't overwrite the previous function. You extend it.
Yes, you're right, because then internally you can call the original function from the standard engine. Yes, absolutely. Makes sense.
Yeah. So this is the point I'm trying to show, right? So you start with a tensor. You say it's a 2-2 shape, and you want to print t for yourself to see. Right? Does that make sense so far? Yep. So you have a square matrix of sorry, not my type, lat long, latitude, longitude and latitudes, and then you can add scalars, for example. You can add this to a bunch of scalars. So if you look carefully, sorry, this should not be, this should be int. Because, you know, because we live in a world where we can represent latitude and longitude, but it's just for fun. But says if you get an int, then we'll just add to the int by itself. Otherwise, you just call the standard engines add. Does that make sense so far?
Yeah.
So now you can do this. Tensor.add AB. T and ones. Let's not bother with the reuse stuff. And yep. Now if we run this, XY, sorry. I'm actually copying and pasting from an existing 75. Ah, right. E. Why is my keyboard not working? So basically, you have a tensor of lat long. Yes, you can have a tensor of your own type, and you can define your own engines on it. And you can define engines to be on your computer. You can define engines to be on other people's computer. The cloud, for example, can be an engine. So what I did in the past was a bit stupid. I bought Raspberry Pis and set them up as a server farm in my computer at home, and then I say, when I add, please use the Raspberry Pi to add while I'm controlling it from my computer. And it turns out that's not such a good idea because Raspberry Pis are very slow.
Yeah, but indeed, if we think about distributed engine, we can take advantages of gRPC communication, protobuf, etc., to allow at least a really faster communication, and we can spread the computation among multiple servers. Well,
that's what you can do with the engine.
Yeah. Wow, that's quite powerful API definition. I'm impressed. I think it's the 10th time I say that. Okay.
So that's the idea of the things that power Gorgonia. The other things that power Gorgonia is basically taking the tree that I showed earlier and turning it into very, very optimized instructions. Now, when I say very, very optimized, remember that Gorgonia is about 5 years old. It's actually slightly older than PyTorch and Tensor. It was announced. I announced it before TensorFlow was announced. So, so it's a bit old. So when I say it's very optimized as of 5 years ago. There are modern things there are modern compiler techniques that have emerged that I have not had the time to actually put it in.
But really impressive work. Really I really like the capabilities of Gorgonia library, and it's very easy. Anyone can test, and you have showed live demos. I really I can learn something from you guys both, and really I really suggest people to learn. And this is very cool live demo, and this is very good library. And again, I am fascinated by this thing. Before starting of TensorFlow project, you have started Gorgonia project.
Yep.
Yeah, so this is quite impressive work, really.
And but TensorFlow has got 22 billion bajillion stars on the internet because Google.
No, it's not about if there are real machine learning thing. If someone want to implement, they can follow Gorgonia. There is not following some project, but it's originally written in Go. So I must say this is one of example why you need to use Go with the machine learning.
Yes. And the thing is, it's clear, right? You will never know that what you will always know that you're working with lat long.
And you can customize it. You can customize Gorgonia. You can do things that cannot do by any product or something. You can always. This is a power of open source. This is the real power of open source. You can customize and you can rebuild things. Really, really fantastic.
The my personal achievement, the thing I like best about Gorgonia was the thing that I built, which takes English languages and translates it into lambda calculus. But I've done things like build AlphaGo in Go, just because fun name. Yeah, you say AlphaGo, it's written in Go. Yeah, yeah. The best thing I've ever done that I like the most is taking it and translating English into lambda calculus.
Yeah,
That was one, and you can execute the lambda calculus, and that's pretty cool.
satisfactory. Yeah.
So
So yeah,
I really like your demo and everything. Anyone want to share anything? You can share, like, if you want to give any kind of advice those who want to, or those who starting
yeah.
learning, like, go with machine learning. Anything suggestion?
I pasted a link in there from Gtography.
Yeah,
There you
this
go.
is,
Yep. So this is a cheat sheet. If you come from Python, if you come from Julia, if you come from MATLAB, I mean,
yeah,
sorry, but 15 years ago MATLAB was cool. Now MATLAB is a bit not that cool, right? I mean, so if you come from Python, you come from the NumPy world. Here are a bunch of tips for you on the
link.
banner. Is that called a banner? Yeah.
Yeah, it's called band.
Yeah, so just check it out. It shows you what the tensor library can do. It shows you what GoNum can do. So the way I think about it is GoNum is like SciPy. You familiar with SciPy?
Yeah, I
And
know.
Tensor is like NumPy.
Yeah,
And then when you need more advanced controls, then you go to use the actual proper Gorgonia library, which gives you all the other controls of the nodes. Right now, the examples I show you, the nodes are basically living in global space, very much like TensorFlow and PyTorch, right? The machine, when you create a variable, it is in global space, but you want to actually constrain that when you're running a deep learning system, so that you constrain all to the minimum amounts that you need to do. That's how you get fast.
what meant Matt? How, like, new programmer can start learning, like, go with the data science or machine learning? Any tips? Any suggestion?
Of course, just look at Gorgonia. After that, look at Spago and try to play. that's that's the best advice I can can give you.
Oh,
Like, I
check out
can say,
Spargo, by the way. It's as a guy who I love the processes in Spargo. I mean, I read through your code. It is a very clean implementation of Gorgonia's instructions. It's amazing. I love it.
Thank you.
clap.
Yeah, I think we will have a lot of fun in the next months, most likely, to combine probably our projects in a way or in the other. We have no clear idea yet. We just know each other. I
Yeah,
think
thanks, Sangam, for bringing us together. I didn't know about
Yeah,
Mateo until today. Well, not
yeah.
today, but
I
yeah,
think I thought, like, I went to both repo, and I thought before, like, I don't know, like, Spargo and Gorgonia. I learned about, like, Spargo, and I thought, like, let's see what Gorgonia do, and he's like talking about let's collaborate and this thing. So I thought it's good to, like, collaborate a community. Like, Gopher Lab is a community, perfect community, where we really discuss things that matter. And really, I want to support open source projects, no matter, like, and I really want to help new generation to adopt this kind of technologies, so they can grow in career and build something beautiful, like you both did. And that's my mission. That's why I created a Gopher Lab, and I'm really happy you both connected some way, and you are shared so much, knowledge to the community. And really appreciate your demo. And I have tried something out with Spargo. Let me try something with Gorgonia. Maybe I can containerize it, and maybe I want to see the, like, you're talking about GPUs, CPUs. How can I, let's say, my concept for both of you, like, I want to, like, just publicly, I have said personally, but let's say you are solving some kind of business problem at the end of the day. Let's say you are talking about GPU, TPU, and nowadays everyone using cloud, power of cloud and everything. Data, there is no buzz of data center, but I can see the future of IoT is coming. And when you think about IoT, there is a machine learning and AI always. And I think you can do like combine this
Edge
thing into
computing.
not edge computing, and you can just like what Nvidia Jetson did with, like, they have SDK, they have a whole thing of stack,
Yeah.
everything built. So let's say if Go can do better than that performance, and you can give that into the machine, like Gorgonia or Spargo, you can run this computation power thing in higher level, like more training, like getting more request, and you are getting more CPU utilization. And when you talk about engines and all, I think this is a we are going forward in future, and this is just start. And I see you can do something kind of product, IoT product, or maybe you can ship your libraries with some kind of IoT device with good computing power. Let's say what Tiny Go, Tiny
Yes, I
Go.
know Tinygo.
So what Tiny Go people did is like very fantastic. I really like. I'm using with my Andrino and Raspberry Pis. So this is like really great, and I see that there is a lot of thing in WebAssembly. WebAssembly,
Yep, yep. I
yeah,
know, I know.
yeah.
So,
People can achieve tremendous thing with, like, Go is like very. You can create a server within few codes.
hmm.
Let's say if you ship that code with help of WebAssembly on some machine or anywhere, basically WebAssembly can run in browser also. So that can leverage lead into the more easy way. You can come up with anything and you can run anywhere.
By the way, do you know Hajime Hoshi?
No, I don't know. You can tell.
Okay, Hajime Hoshi is a programmer in Japan, and he
Mm.
wrote a library in Go called Ebi10. It's a
You can
game
share.
library.
You can share. I will display on
Yeah.
screen so people can get context.
Anyway, this guy, he wrote Ebi10, and he also wrote a new program 2 or 3 days ago called Go to CPP. You know what it does? It takes a Go program, compiles it to WSM,
Mm.
and then from WASM transpiles that into C++.
Oh, that's something like fantastic. Like
That's
you are taking
crazy. And I was like, it's like, I was,
like
oh, fucking hell.
like it's taking code, converting, like WebAssembly is like completely new web thing, and
Yep.
that again C++, that is like unbelievable.
Yeah. So let me give you that. I think it's go to C++.
Yeah,
Okay, so the link is sent to you.
yeah. You can share screen also if you want to show
There you
something
go.
demo. Yeah, let me show the screen. Yeah, this is the link.
So yeah, that's crazy. Speaking of WASM, people have done work on Gorgonia. Olivier has done, the French guys basically have done work on turning Gorgonia stuff into WASM and then deploying them to the cloud using WASM.
I want to try that one. I want to try that one. You can share with me. So I want to run this WASM thing on a cloud. Let's see. We need a dependencies. We containerize it and we ship it. Let's say if we ship WASM and we can ship anywhere, that can save a lot of dependencies.
Yeah, so he basically made an RNN, LSTM in Go, compiled it to WASM, and put it on his website. It's pretty cool. And then there's another guy, Nabil, also French, who is doing stuff on Gorgonia on TinyCode. So they're contributors to Gorgonia, for example. Yeah.
Really nice, really nice. Like
Really
uh,
enjoyed this conversation. And many thanks to both of you.
Yeah, really, I personally enjoyed demo, and
Yep.
I really like both. And I'm going to test now Gorgonia. I got pretty much overview and everything. I'm always ready to explore things, and I always wanted to add something like not my kind of flavor, but how whatever comes in mind, I work on that. Maybe I can study on that. It's always good to learn new thing. And maybe I
Yep.
can learn this new thing. That is the way of my learning. And
Mm.
sharing is a can if you learn and share, that can make you perfect more. I think rather than for the some kind of result and some kind of achievement, you always learn for like
Your
how
sake
things
of
work.
learning.
Yeah, sake of learning. Always, everyone is sake of learning.
I learn for the sake of learning. I mean, I got nonsense here. So yeah.
Yeah. So I'm going to try this one project. I really recommend and join this Discord channel. Those who are watching, this is the link. You can join the Discord. Both are there. Chu is there. Matt is there. And really, I'm now creating a separate channel for ML and machine learning on Discord, so people
All
can
right.
jump, talk, and really like looking forward to like support you guys or any kind of like there is go ml project and lot of project like I can uh, as I learn more thing, i I will create something and I will share with community. And also like next stream will be like rust. I'm taking basic rust. Those who wanted to learn, those are like not familiar with programming also, welcome. Even I have learned Rust in like few months. I'm still learning, and it's always I believe in sharing. And thank you both of you for joining and sharing your knowledge, supporting the community, and I really like your like when people say like yes and collaboration thing and do some kind of better thing. I really like that one. I
Yeah.
really like when people get success, when everyone success and happy, that is the thing. Rather than a community work or there is need, we need some kind of motivation. And as a human we learn in team, and I really believe in community learning. I really like your both project and looking forward your collaborative work, what will come in
So
output.
exciting! My God, the things that I can do. Spargo is so focused. Is so beautiful. Oh my God.
Many thanks.
You know something, Sangam? I actually started a tensor fork of like Spargo's changing Spargo's underlying matrices to use tensor,
Mhm.
just to play around to see. I'm so excited, man.
Yeah, I got like your enthusiasm when you mailed me, and I thought like, okay, let's do another stream to get to know each other and share to community, and maybe I can learn something. And you have done tremendous work on both a GitHub. How to maintain a open source project is really, I think, really needed for the beginners or maybe those who coming to the computer science. Maybe they don't know GitHub. What is the GitHub? Rather than spending a time on some other social media or some other thing, I recommend to spend on GitHub is your social media. You can go and explore. There's
Yep.
tons of library and really impressive work. By the way, for both of you, I have one suggestion or maybe opinion. There is a something called GitOps or Git pods or Git actions.
GitHub Actions.
No, GitHub actions. Yeah.
Okay,
So
I
use
know what
GitHub
GitHub
action.
Action. Yeah,
Yeah,
I
you can use GitHub action and you can run some kind of server or something
yes. Yep.
that can give a better understanding for those who newcomers. They can test directly there. Yeah.
What do you mean? So we Gorgonia uses GitHub Actions for testing.
Okay, for testing use, like when I let's say I have one kind of server running
Yep.
and it will open some kind of link and what Gorgonia will take some kind of argument. Maybe you have some kind of NLP or machine learning examples.
Yep.
So you can user can pass that and they can check output. So this way, because GitHub action is free. for
Yep.
some kind of limit, so people can
Yep.
use it. And there is
Oh, so
Git
like a
for.
playground but powered by GitHub Actions. Like Go Playground.
Yeah, I know Go Playground.
Yeah.
And
So
one of the thing, Play with Go. Did you know Play with Go? New
no.
project by who created a Play with Docker. This guy is creating now Play with Go. You can
Okay.
really check it out. I really support this guy, Neil Marcos. He's a Docker captain.
Cool.
Really like his contribution to the communities, different communities. Let me share you link. You can check it out, or maybe it's. Let me display on screen. Add a banner, and this is the link. Playwithgo.dev. uh, so you can go and you have all the kind of playground is better than Play with Docker, not Play with Docker, Go Playground. And you can like sign in and do. There are a lot of contribution going on in Go community. I really
Yep.
recommend to go, and it's like very fresh project. Recently he started 3 months back maybe.
Yep.
I really appreciate this guy. Like he is done. Marcos is done like really tremendous work in Docker community and again Go community also.
Oh.
Yeah,
Is this done with actions?
not action. It's done with some kind of sandboxing particular environment.
Yep. Yep.
It's like Docker in Docker. Running Docker in Docker is like creating a particular, for everyone there is a session. You will get own environment when you log in, and
Mm.
after that you can do code, you can mod and everything, try it out. And
Cool.
basically it's very cool to run things. I really like the Marcos work, and he's done really uh, tremendous work on this. And this you can contribute also. I really suggest you can contribute also.
Yep.
Yeah,
Yeah, I do.
you can add a Spago and Gorgonia examples there. So people
Yep.
those who are new, they can just click it and everything is running in their environment machine. And here you go.
That's
Like
nice.
Yeah, yeah,
you,
good idea.
Very good idea.
Absolutely.
Huh.
yeah. So always I share something. So
Yeah. I've learned a lot.
so even I have learned a lot, all about community, all about sharing. So this is the link. I really recommend to join this Discord channel. We have around 500 Gopher people, Go developer, and those who wanted to learn. And I really share the Git repos there. Go check Go GitHub channel. There are a lot of cool. One of the cool things in Go, whatever the new library, maybe small library also you can find. I'm not a big fan of famous libraries or Git star. I really care about what kind of problem solving. So go and
Yep.
check. And we have like podcast channel. We have Go Weekly, so you will get weekly newsletters so people can read. And that we are doing like episodes also. Let's see in the next episode. Maybe I can take some kind of workshop, small workshop, so people can learn rather than jumping at high level topics.
Yep.
So we can maintain both level, like some talks for those who already know Go and those who wanted to learn. And thank you both of you. It's like really fantastic. Really enjoyed. I
Thank you.
like when I really like when people enjoy the stream, and I really like live demos on screen. And really, you're the fantastic, Chu. Like
Thank you.
I really like.
Thank you.
Anything you want to share again?
Not really. I mean, the tensor library. Oh, maybe it might be actually helpful to say that the tensor library, if you have your data in NumPy, tensor library works with NumPy files. If you have your data in Apache Arrow, guess what? It works. So there are all these connectors that works with tensor. So it doesn't really have to worry. You don't have to worry where your data is. It just works. Yeah.
Yeah.
Check it out. And if you need help, maybe also don't use the master version because I am I'm porting over some new semantics into Tensor and Gorgonia. So don't use the master versions. Use the tagged versions.
Thank you.
Thank you.
Yeah, one more thing, subscribe to this channel for future updates and future episodes, and join the
Can I do
community.
this? Can I do this?
Yeah, yeah,
Smash the like button.
smash
Click
the like,
subscribe. Don't forget to click the bell.
and you can click the bell icon. So always stay updated, like softwares and libraries.
Sorry,
You,
I've
Matt,
always wanted to do that on YouTube.
yeah, you wanted to do anything, Matt?
No,
No, thanks. I'm fine. I'm fine like that.
sorry,
Thank
you're
you.
on your own, mate.
Yeah.
All right.
Thank you, everyone. Now, bye
Thank you.
bye.
Bye.
Thank you. Bye.
I'm ending the stream.